Hello, and this is my second laboratory exercise with my subject data communication and networking. So the activity title is building network topology and design. So I'm gonna go straight to the procedure. So number one is open packet tracer program and choose simulation mode. So this is my packet tracer. I'm gonna go to simulation mode. Okay. Yes. Next is single click on end device and single click on generic host. So for my version of Packet Tracer, there's no generic, so I'm gonna click this PC here as okay. Then next is uh, add three more hosts as shown below. So I'm gonna add three more PC. Three, one, two, and three. Okay. Next is connect PC0 and PC1 to switch 0 and PC2 and PC3 to switch 1. You can use any switch model, but for this experiment, select 295024. Add switch by moving the plus sign below PC0 and PC1. Connect PC0 and PC1 by first choosing connections. Okay, so I'm gonna add a switch, the model 295024 below PC0 and PC1. Okay, and another switch underneath this PC2 and PC3. Okay, so choosing connection, click the copper straight through cable. Okay, so connections, copper straight through cable. So PC1, PC2, gonna connect here. Okay. Okay, configure 0 by clicking it once, choose fast internet and drag it to a cursor to switch 0 just as shown below. So I already did that. This one is shown below. Okay, notice a green light on PC0 internet and amber light on switch 0. Fast internet 01 port means that it is temporarily not forwarding frames. Wait for 30 seconds and the amber light will change to green, indicating the port is already forwarding state. Okay. 10 is repeat the step number 5 to 10, but this time use PC2 to PC3 to another switch. The actual switch port does not matter. Okay. So okay, I'm gonna go straight through. Plus it 0. Okay, so green and the switch 0 is an amber light. Okay, I'm gonna do the same procedure for this PC2 to switch 1. Okay, let's switch 1. Oops, sorry, I misclicked the. Okay, so now they are in amber light for switch 0 and switch 1. So this is in processing stage. I need to wait until they become in color green, so that we will know that they are in forwarding stage already. It's okay, 1 minute. So I can choose this. Oops. Okay. Okay, so they are now on green. This PC here, PC 3, still in. Choose this. Okay, so now they are in a forwarding stage now. So this switch 0 is communicating with PC 0 and PC 1, and switch 1 is connected to PC 2 and PC 3. They are now in a forwarding stage. Both sides are in color green now and forwarding stage. So next, uh, number 11 is using the step 1 to 10. Construct the following topologies using 5 PC, 3 laptop, and 1 printer, at least 2 switches or hubs. It depends on your design. There are should be green light indicating the frames already forwarded. So first is bus topology, star topology, ring topology, mesh topology, and hybrid. Okay, so first I'm gonna do the bus topology. Okay, so first I'm gonna choose the 5 PC, PC 1, 2, 3, 4, 5, 6. Oops, remove this one. Next is 3 laptop. Okay, it's 3 laptop and 1 printer. Okay, so this is, okay, let me choose this. I'm gonna use the switch. I'm gonna use the same model of the switch, 295024. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so for same devices we use the crossover cable, or okay, so something like one. Okay, so both are red, or I'm gonna use this one. They will automatically connect this. Okay, okay. Next is connect the PC to the switch. Okay, PC here, laptop here, and the printer. Connect to the switch. Let me put some notes here. This is the bus topology. Okay. This is the bus topology. Next will be star topology. So for star topology, I'll do the same again. 5 PC. 1, 2, 3, 4, 5, and 3 laptop. 2, 3, and 1 printer. Okay, and I'm gonna use only one switch in the middle and connect all of these end devices to this switch. Okay, I'm gonna use this here, straight through cable. So, bus topology, star topology. So this is the star. Star topology. Okay, so bus topologies, star topology. Next is we have the ring topology. Okay, you can use the 5 PC again and 3 laptop and 1 printer. So in device PC is 1, 2, 3, 4, 5, and 1 laptop. I mean 3 laptop. 1, 2, 3, and 1 printer. Okay, so ring topology, gonna use the same model of the switch 259 295024 2 3 4 5 6 7 8 9. Okay, let's put this here. Okay, so I'm gonna connect these switches to each other like this. Use this. Okay. connect the PC, each PC to each switch. This one. So now the laptops here. Here. Now, here. Okay, so printer. So this is the ring topology. Okay, so ring topology. Okay, star topology. So bus topology, star topology, ring topology. Okay, next is so mesh topology. So for mesh topology, there are two types of mesh. That is the full mesh and the partial mesh. So use this. Let's see. So for mesh topology, uh, first I'm gonna do the full mesh topology. Let's see, it's A. First I'm gonna use the switches. Same. Use the switch 2950. So for full mesh, I'm gonna use switch to say to okay. So for full mesh, they are uh, fully connected with each one. So I'm gonna use this. I'm gonna connect them. Okay, this switch here, switch 21 to here, this switch here. Okay, then this switch number 22, switch 24, here, okay, this here, okay, so next this one here. So this is the full mesh topology. So all the switches are in they are connected with one each and every switch. Okay, next thing is I'm gonna add the end devices. So 5 PCs, 5 PC, 5 PC, then 3 laptop and 1 printer. Then goes automatically choose a wire. Okay, let's put this here and connect this here. Let's printer here. Okay, so this is the full mesh in mesh topology. Next type of mesh is the partial mesh. Okay, so this letter B, let's see here, partial, it's capital, partial mesh. Okay, zoom out a little. Okay, so I'm gonna use the same type of switch. Okay, it's here. Um, okay, so for partial mesh, so they are partially connected. This one here. Okay, and then I'm gonna connect this. Then this one here. Okay, so this is the partial mesh. They are partially connected. So this PC, this switch number 26 is fully connected to the other switch, while the other they are partially connected. Okay, and then I'm gonna add the end devices. So 5 PC, this one, two, three, 4, 5, and 3 laptop, 1, 2, 3, and 1 printer. Let's connect them to the switch. Put this piece here. Okay, so this is the full mesh and partial mesh for mesh topology. Okay, so we have that green, star bus topology, and next is hybrid topology. Okay, for hybrid topology, I'm gonna use hybrid topology. So for hybrid topology, I think I can just combine this topology, mesh topology, for like full mesh and partial mesh. Okay, so I'm gonna use switch hybrid topology. Let's say for this one, switch this, and then this one. The switch here. Let's say I have full mesh here on the top. Let's make them full mesh. So this one here is a full mesh. Okay. And then the next switches will be just a partial mesh. So like this. Go here. Partial. So this one is partial mesh, they are partially connected, and this one is full mesh. So this will be my hybrid topology. Next is add the end devices. So 5 PC, 1, 2, 3, 4, 5, 3 laptop, 1 here, okay, and 1 printer. There's the printer here. I'm gonna do, now I'm gonna connect the end devices to the switch. See that. Add this here. Wait. Let's 1 minute. Oops. Okay, so now this is my hybrid topology. Okay, so let's check bus topology, star topology, ring topology, mesh topology, and hybrid topology. Okay, so this is my bus topology. Okay, next is the ring topology, star topology, ring topology, and then mesh topology with full mesh and partial mesh. And for my hybrid topology, so I use full mesh on the top and partial mesh on the bottom. Okay, next step is Okay, so what does the amber and green light indicate in Cisco packet tracer? So, 1 minute. I'm gonna use this pen. Oops, wait. Okay, so I'm gonna go here. Okay, so the amber light in this Cisco packet tracer, it means that uh, the switch is in a processing stage where the, what do we call the, wait, here's the pen, this, yeah, wait, hold on a minute. So what we call the this amber light here, it means that it is in a process stage where the switch is in what do you call this? By default, I mean this switch by default, their spanning tree is turned on by default. So what we call the STP. So because of that, the switch is checking whether there is a switching loop on the network. So before they turn on the interface, first they are sending they are checking their, what they call this, their ID. I mean the bridge ID of the, what will be the primary bridge to avoid the switching loop. Okay, so that, hold on, not okay. Gonna clear this and a minute. But so okay, so because of, I'm gonna write this spanning tree protocol. Okay, so because of the spanning tree protocol or STP, that's why it's in amber stage, because our switch first they are checking whether there is a switching loop. Then let's say for example, I'm gonna, oh my god, I'm gonna use again this pen. Wait, bear with me. Okay, let's say for example, wait, I'm gonna use color green or no, amber color. Let's say for example, this PC here wants to communicate with this laptop here. So in order to do that, this PC, let's say for example, this PC knows the IP address of this laptop, but in order to for them to communicate, this PC needs to know the what is the MAC address of this PC. I mean this laptop, so that they can communicate, so they can do the, what do we call the, three-way 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 handshake. Wait, hold on a minute. Wait, they can use the three-way handshake. So what this PC gonna do is he will gonna send an ARP message. ARP, because so an ARP message will be a broadcast message where this PC here, we're gonna send an ARP message to this switch. So what this switch gonna do is send the ARP message or forward that ARP message to all these active interfaces. So let's say, for example, this ARP message will be forwarded to this interface here, here. All of the switches will receive that message. So until this laptop here uh, receive that ARP message, then he will tell this PC here that it was his IP address, and then he will give the MAC address. But since it's an ARP message, they will keep the switches will keep forwarding that message around the network. So except for they will gonna forward the message around the all their active interfaces, but except for the interface where they receive the ARP message, so they will gonna forward it. So for example, this switch does not have this switch is turned off. I mean, if this switch is turned on, I mean all the switches interface is turned on, then they will just keep broadcasting that message all around the network. Say for example, this interface here, we're gonna forward the ARP message here, 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 and back to him. So it will gonna cause what do we call the broadcast storm, or broadcast storm. So that is what will gonna happen. What So our network will go down because we will receive unlimited broadcast or unlimited broadcast of that packet around the network. So so that's why the switches first they are checking where there is a switching loop, checking if there is a switching loop. Okay, so let's clear this way. Okay, so network is checking, the switches is checking whether is a switching loop, so they turn off this bridge here, so to avoid the switching loop. Then if let's say for example this switch here, they it's color green, this means that it's okay to turn on this uh, interface port here. So it's both side are green, so this is their uh, bridge. Okay, so the amber color for the switch is means that it's in process stage, and when it becomes green, it becomes on the forwarding stage. So first the notepad. So green means forwarding stage, then amber means processing stage. Okay, next question is, okay, Next is what do you think is the topology? Number two, what is the function of the switch and hub? So the function of switch and hub is almost the same, but they are different the way they handle the data. So let's say, for example, this one here, I'm gonna use, I think I say, for example, I'm gonna use, say, hub. There's a hub here, then this PC here, 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 and here. So let's do this, connect to the hub. Okay, so let's say, for example, this PC here wants to communicate with this PC. So that switch is, I mean, the hub is not that intelligent where how he handle the data, because, for example, this PC wants to, let's say, I'm gonna use this again. Say this PC here wants to communicate with this PC, okay, but let's say this one, it will forward the packet to the hub. Once the hub receive the packet, what he will do is forward the packet data to another PC. This PC here will gonna receive that packet as well, and this PC here will also receive that packet. So the hub is not that intelligent the way he handle the data. So unlike on the switch, say, hold on a minute. Let's say I'm gonna use again the switch. Let's say this is the switch and the end device. I'm gonna use three more pieces. Okay. Okay, and then let's wait for them to connect. It's in processing stage. It's amber light. Okay, so for example, this PC here. Wait, so let's say this PC here wants to communicate with this PC. So what your uh, once this PC send the packet and the switch receive that packet, what the switch will do is gonna find what is the where this packet needs to go. It will gonna look for its uh, MAC address. MAC address. So gonna look for the MAC address where he will gonna send that data to its port. Okay, so it will gonna look for its MAC table address in its memory. So he will just gonna send that packet to this PC here without this receiving that packet. Okay, so clear the screen. Hold on a minute. It's still in Amber stage. Just they're not forwarding. Anyway, so that is the function of switch and hub. So number three, what do you think is the topology that only uses single medium? I think single medium. I think it is in the bus topology because before, long time ago, I think in the olden days, where the EI TIA standard does not exist yet. There is no IATIA standard where there is no copper cable. So before they are using the coaxial cable to connect to the network. So it's the coaxial cable. I don't know how to is coax coaxial cable. This. So in the olden days, they are using this cable to connect to the network. So they are only using this single medium to connect, and they connect this to a hub and a bridge. So they're using this. Collision in the there is a lot of collision in the network during that time. So they are using only one single medium, and this is what they are using. So, for example, limits. Let's look in. So, say for example, it's not available. Okay, so use green. For example, this bus topology here, only use the coaxial cable. Ayun. Here, the sample, there is only one coaxial cable for all this PC. They are connected here, 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 here. This is what we call this, the coaxial cable here. This one, for example, that one is this coaxial cable. Then there is the, there was there is a, let's say, a hub here to extend the coaxial cable line. Then there is another PC here. You see here, you see here. And then the coaxial cable is also. Just gonna write this. Okay, here they're connected here. Yeah, an example only. This one. So whenever this one will communicate to this PC, we're gonna send the signal here, here. So whenever this PC wants to send a file, the other PC must not send a message. So they can only send one by one. So that was the bus topology before using the coaxial cable. or that single single medium. Okay, next is okay. Next, so what can you conclude from this activity? So with this activity, I learned how to uh, use the topologies and use the topology in the network without using the real device. Or with this packet tracer, I learned how to use use this topology and without buying the real device like Cisco router, which is quite expensive router. And I learned what are the function of the switch and hub and other devices. Um, so I think that's it. Okay, I think I'm done. So thank you.